Okay, the final module of Chapter 13 will look at calculating the Greeks using a binomial lattice. This is often the case in practice. If we price the binomial, we use the binomial lattice to price the call, that would be the logical basis on which to evaluate our Greeks. So let's see how that might be done. First of all, in theory, to calculate the delta of a call, we really ought to construct two binomial lattices. One where we start with the price of S, and one where we change the price to something a little bit different. Create a new binomial lattice, create a new price, and then we approximate the delta, the derivative, by this formula. What's done in practice typically is to try to use the information from the original lattice to approximate this delta. And so here's an example of the formula we saw in the earlier chapter where we were using the binomial lattice to construct a replicating portfolio. And so this is an approach that uses, as we can see, only information from the original lattice. We use the call price at time h, the up and the down call price, and this is the formula we got for delta in our replicating portfolio. This can also be thought of as an adjusted value of delta at time h of a stock price that's intermediate between the up and the down price. And some authors will use that approach. But what we have in the book is we will use delta consistent with the delta in the replicating portfolio. Gamma is the derivative of delta. So one could say that, in fact, we need, to do this theoretically correctly, we need a delta on the original lattice, which takes two lattices, and a delta on an adjusted lattice. Again, what we want to do is to use only the information from the original lattice and not create new lattices. And the approximation in the book is to say, let's calculate the deltas at time h. Recall we have a binomial lattice. So this is time h. This is time 2h. We calculate a delta here. This is what I'll call delta D. And we can calculate a delta here, delta U. And we've done this in the earlier binomial lattices where delta U reflects the up and the down from that state. Delta D reflects the up and the down from that state. And from those two deltas, we divide by the change in the stock price at those states, and we get an approximation for gamma. And again, sometimes if one used that other interpretation of the delta at time 0, you would get a slightly different formula for gamma. And you might have seen this in other books. But we'll use the one from this book. And finally, theta is a time derivative. So how do we calculate a time derivative? Well, in effect, we need to shorten up the lattice a little bit. That's not practical. But what it is useful is to go back to our general approximation formula for a call price, where we use delta, gamma, and theta. We have an approximation we've seen earlier. And once we've calculated delta and gamma from the binomial lattice using the formulas we saw, and we have both of these stock call prices, we have the call price at 0 and the call price at UD. What's UD? Well, that's the price here. This is the stock price UD. This is the stock price at 0. So we're using the stock price in 2 time steps, and we calculate the call value there. And that we have the call value at time 0. We have delta, gamma, and we simply solve for theta. And this is the formula we get. That's it.